Welcome back. This is the 10th annual virtual residency workshop. This is Thursday, June 27, 2024. And our session now is facilitating artificial intelligence, machine learning, and deep learning. Our moderator for this panel is Dan Bross. I'm Henry Neiman, your host. Dan, take it away.
Okay, hello there, everybody. I'll be the moderator. I'm coming from Francis Marion University in South Carolina, campus champion there. And I'm going to go ahead and let the panelists introduce themselves. I guess if you want to go in alphabetical order, guys.
Hi, everyone. My name is David Apostle. I'm a research and education facilitator at the University of North Dakota, also a campus champion. I've been in that role about 4 years, and I've been really focused on AI for a couple of years now. Looking forward to the exciting discussion.
I'm Phil Boarding at Alabama A&M University in Huntsville, Alabama. That's an HBCU. I'm a research professor there, and I've been doing what I would call fundamental machine learning with trying to get machine learning algorithms to run in hardware so they do things faster.
Awesome. Hey, everyone. My name is Chris Endeman. I work at the University of Wisconsin-Madison as a data science facilitator. And as part of that role, I teach carpentries workshops, host consultations, and I also lead a machine learning community of practice on campus, which welcomes practitioners of all backgrounds and skill levels. We're trying to make machine learning and AI a little bit more accessible to all the fields that are trying to use it nowadays. And prior to this role, I worked in the field of computational neuroscience, which gave me a lot of exposure to AI and machine learning.
Hi, I'm Sheldon Liang. Currently, I'm a department chair at Lane College in Jackson, Tennessee. I have been in IT for more than 40 years. And even 30 years ago, I already started very interested in AI and machine learning. So I would say now I'm still working on this, crazy about it. I claim myself as a principal inventor of YCIO that helps web-based intelligent services with universal interface and the user-centered experience without the coding at all. Thank you.
Hi, everyone. My name is John Nyheis. I am a business relationship manager at the Fred Hutchinson Cancer Center. We're part of the larger University of Washington Medical Center ecosystem, along with Seattle Children's Hospital, Harvard Medical Center, UW Medical Center, et cetera, et cetera. My role as a business relationship manager basically means that I represent two research divisions, Public Health Sciences and the Shared Resource Division. My role, along with four other teammates, we basically take concerns and requests from the scientific research community up through administration and help them achieve their ends. Recently, we just applied for a $2 million S10 with the intent of adding GPU resources to support AI research here at the Fred Hutch. And for that, we coordinated everyone together. I ran a NVIDIA GPU Lunch and Learn, where we talked about the technical details with all of our researchers to sort of spec out the architecture that we needed to move ahead. So I'm really looking forward to this talk. Thank you, everyone.
All right, and last, I'm Dr. Christopher S. Simmons. I normally go by Chris, but for this session, I'll go by Christopher to avoid the namespace collision. I'm the Deputy Executive Director of the Massachusetts Green High Performance Computing Center, which is the supercomputing center for MIT, Harvard, Boston University, Northeastern, UMass system, and as of a few months ago, Yale. At MGHPCC, I work on developing shared services, including supporting a research cloud that does OpenStack and OpenShift as a service, focusing on AI, ML, and generative AI workloads. I also work on several national efforts where I'm on the leadership team for the Open Storage Network that provides a cloud-native object store as a service for the Access program. And in my spare time, nights and weekends, I run the OpenHPC project. Thank you very much.
Okay, sounds like we got everybody. Go ahead and head towards the first question that's here. If anybody is able to check the chat, That'd be very helpful. I'm trying to work a couple windows.
I'll keep an eye on it.
Thank you. Okay, so the first question we have here is when a researcher who wants to use AI, ML, or DL in their research first comes to you, typically how much experience with these three and how much understanding of it do they come with?
Well, speaking from my experience, we have researchers from across the entire spectrum, from grad students to highly experienced, very accomplished, senior level primary investigators. So a big part of what we have to do is we sort of have to ask a number of leading questions to figure out what it is they're actually trying to accomplish and sort of where they're starting from.
I would agree with that. It is a broad range of backgrounds. I would say some people have an impression of AI as being kind of a turnkey solution. They really don't seem to be appreciate all of the hyperparameters or the different configurations that can affect the accuracy of their results. And they don't seem to appreciate that they should maybe train their model multiple times to get a good feel for just how general it is.
Yeah, so when I start working with researchers, I tend to put them into two categories, right? Those who are tool developers versus those who are tool consumers, and those who are doing AI research and those who are doing science research that happens to use AI, right? You're talking like PyTorch and TensorFlow versus like AlphaFold, right? And so historically, about a decade ago, almost everyone was a tool developer. And mostly they just needed to know, how to update my software stack, how do I run on a GPU, and they're off and running. But, these days we have a lot more tool consumers than tool developers. I would say the ratio, is probably on the order of 100-1 to 1,001 these days, where a lot more people are consuming software than developing software. And that the sort of help requests we get these days require a much deeper level of facilitation. Where historically it was just hand-holding to get them to install software, now you need a whole consulting framework around choosing what models to use, right? Choosing what software to use, and how to bring sort of the magic bullet that everyone thinks AI ML is to their specific, domain-specific problem.
So to support what Christopher was saying, I've had great luck with Hugging Face. I don't know if you're aware of this, but this is an open source community. People are submitting their AI models there. Frequently, when I have a new grad student, for example, who comes to me with a problem, I will point them there and say, hey, look, it may be that someone has actually already developed, the tool you need to do this. Here, I'll see if I can paste the URL in the chat.
Yeah, I mean, I think one of the difficult things about facilitating this field in general is that it's so broad. Like machine learning and AI, there's so many kinds of models. There's deep learning, there's reinforcement learning, transformer models. And so people can have all sorts of skill levels and backgrounds, and that's going to heavily depend on what specific application area they're coming from. So folks in maybe psychology, they will oftentimes be maybe somewhat familiar with like regression models. But things like neural networks, they're going to need some more practice with.
Personally, myself, I have special experience. More than 30 years ago, I started working on we claimed the most sophisticated AI. That means how to create compiler for the very comprehensive, very complex programming language like Ada, recommended by DoD. So back then, we focused on formal language processing. Now we toward to natural language processing. So to my knowledge, the basic idea, even I started to pick AI up. That's more about the data-driven processing automation. So one of the hardest part is adaptability. How to make your solution based on data to drive the processing automation to be adaptable. So eventually we figure out the knowledge base is needed. the content of the knowledge could be revealable, or you can put it there. So I would say when we talk about a model, so model usually based on the knowledge base. So you can use the knowledge base to enhance different aspects across different industrial applications. That's my personal experience. Thank you.
We have a notion in the chat about the NVIDIA developer program, and I highly recommend that as well. But you have to be a little careful. I took a workshop just a few weeks ago at Wichita State at the Oak supercomputing, just before the supercomputing meeting. And we did the NVIDIA workshop. We did the first module in NVIDIA, and we were doing the NIST number recognition things, the character recognitions of digits. The difficulty was we didn't get any visual output of the failures of the artificial intelligence recognizing system. Okay. The machine learning thing was recognize the numbers 1, 2, 3, 4 with a 95% accuracy, but we failed to see the 5% rejections. So I caution the users, especially the facilitators, make sure the users have ways of seeing what doesn't work right with their system so they can identify what I would call a fatal flaw, or maybe it's rejecting perfectly good data, but it's not got a mechanism for identifying it. So I'm really big on visualization of outputs from any kind of computer program, including linear equation solvers. All right. It can be done, and you need to see what the data looks like.
I think Phil brings up a very good point. And to take it a step further, most institutions, my institution, has an actual AI policy, which kind of can strictly control like what data you can share, what data can be added to a public model. And so you need to make sure that you cover this with your researchers as well, because they may be assuming that they can just plug their data into a large compute cloud type situation, and they're not allowed to do that because it contains PHI or is potentially patentable, or so you need to make sure that you cover the policy requirements as well, and you have to understand their data well enough to sort of give them some guidance, or at least point them in the right direction as far as getting approvals. So that can also be something that is pretty critical to cover, I think, in the initial facilitation.
Totally agree 100%. I gave a talk yesterday on governance and compliance around data used to drive AI workflows. We're kind of right now in the wild west of the generative AI era, and everyone's just throwing everything against the wall and letting God sort it out and hope there's no IP issues. But that's something we need to think about, especially anything that intersects with patient data, whether you think it's been de-identified or not, right? You definitely need to CYA.
Well, but even if you're doing AlphaFold and you're potentially developing an antigen or something that could be used in a treatment, it's potentially patentable. So there's just anonymization isn't just the only thing you have to worry about.
May I have some response to Dana Strong regarding web-driven interfacing?
Okay. Yeah, sure.
Thank you. Currently, I have 4 students with me through summer research. They are HBCU students, but they're doing a great job. One of our solutions, the focus is on universal interface. The other user-centered experience. So the experimental case study, we can embrace in the same time to have multiple websites that can allow us to collect maybe over thousands of items together, but to be presented in the universal interface. And also with a user-centered experience, what I mean, that means you can explore browsing all the things. You don't need to swap the web pages. This is number 1. Number 2, we have another idea about a magic gift. G means grouping. I means indexing, those kind of things. That allows you to have focus for faster, rapid lookup. But this is all based on machine learning and we say multi-OLAP, online analytical processing. So this is pretty much like a deep learning. So basically, we have a machine learning mechanism. Then we have the multi-OLAP, which means the deep learning together. That's why my students working on this, we call it digital innovation, to pull over maybe more than hundreds of websites to have the content. The number of content would be maybe say 1,000, but sometimes too much. We're going to apply magic gift. That's automated. You can have the grouping. For instance, the same topic, they are grouping. So that is going to narrow down the topic you want to look up. So that's pretty much something to answer Diana Strong's question. Thank you.
Just a couple more comments on some more graphical user interfaces and ways to get access to lower barrier of entry AI/ML workflows. On HPC systems, for IT or sysadmins, I highly recommend looking at the Open on Demand ecosystem. Right, Open on Demand provides an HTML5, so no plugin, web portal to your HPC systems, gives you Jupyter notebooks, RStudio, virtual desktops, et cetera, as a service. Also, I wouldn't overlook Google Colab's free tier. You can get a lot done, especially if you're a new researcher, just using Google Colab's free tier. You might get on an old K80 or a P100 and not have access to latest and greatest, but it's a great way to get started in learning. Lastly, I would really like to promote Nautilus. Nautilus is part of the National Research Platform, which is developed out of the West Coast team, San Diego and those folks, who do Kubernetes as a service. You buy the hardware, they federate you into Nautilus, and they run it for you. They refer to Nautilus as potluck computing, right? Bring your own resources, or stone supercomputing, if you're familiar with that fable. That's my particular favorite term. But they'll run Jupyter Hub for you. So it's basically a nice way to get Kubernetes on your campus and start getting access to not only Jupyter Hub through NRP, but if you get more sophisticated, you can deploy Kubeflow and start doing sort of AI/ML as a service, right, for your campus.
To mention another GUI-based tool, here at the Fred Hutch, we've developed a tool called Zero.bio. This actually just completed FedRAMP and is now being implemented at a variety of different universities. This is not specific for AI, but we have a lot of researchers who are wet lab folks, for example, who really are not programming oriented, and they just need a GUI and like a place that can plug in their data and have some pre-built pipelines, pre-built analyses run on them. So this is something that's becoming available everywhere. It's not free, unfortunately, because it uses AWS at the back end, so you got to give AWS your credit card. But it's something that's worth checking out. And they're adding new tools and new pipelines to it at all the time. I'll see if I can paste that into the chat.
Okay.
Any other comments? Oh, sorry, Chris, go ahead.
Well, sorry, it's kind of a tangent, but I saw Em posted the question, is the philosophy of lowering the barrier to entry actually appropriate for all AI/ML workflows?
And I just no, not
yeah.
Well, definitely. I think we definitely need to do a better job lowering the barrier of entry, right? AI/ML and the cloud have long been advertised as the great democratizer, and I think they've done nothing but increase the divide between the haves and the have-nots. When an H100 costs $30,000, it's hard to, a single graphics card, it's hard to get involved. But I think in general, Jupyter notebooks and these lower barrier of entry web tools is where we start. It's not where we end up. I'm a big proponent of automation, better documentation, better tools, particularly those that use declarative as opposed to procedural paradigms in order to enable reproducible computing. Because reproducibility in AI/ML is a huge problem, and I don't want to go on a diatribe, so I'll shut up now.
Well, yeah. Christopher, one of the things that a mentor of mine for many, many years lectured on was if you're going to solve a problem, build the best model that you can of the problem you're trying to solve, get it to get the answers, get it to generate answers from the input that you're using, okay? Go with this model, not the real stuff, but the model, and make that all work. If you can't make a model system work, then don't throw a bunch of real data in something and get the garbage out for what you've got to know that the logical processes that you're going to use work. So, for instance, let's see, I'll give a simple example. You know how to play a game of bridge. So you deal out the cards, you've got four hands, you play the bridge game, and you see if the AI machine will play the bridge game in some logical way. Okay? Because if it won't, then don't go any farther. All right? Build some sort of working system. It can still use AI, but the test data generates the results that you expect, not the results you don't expect. Okay. And once you get that work, then you can try the real data. But you always have to fall back to understanding, am I really doing something correctly? Anyway.
Yeah, I mean, I
Yeah,
think
definitely. Go ahead.
for M's original question of lowering the barrier to entry, I mean, I think there are certain things that can be kind of abstracted away that you don't necessarily need a PhD in computer science to be doing these kinds of things, like fitting a deep learning model. You can do that with a few lines of Python code. But you need to know some of the dangers and risks. And that's really the important thing. It's like, to use the analogy of driving a car, we don't expect every licensed driver to know how to replace their engine. I don't expect everyone using deep learning to know how to compute gradient descent by hand. And I don't think they're going to need to in most cases. But I think you still need to educate them on some of the risks and the problem areas for them to use those technologies safely.
Yeah, totally agree. I think we're going to see commoditization of the AI ML stack really quick, right? Just like you no longer write out your own LU decomposition or gradient descent, you consume a library. You know, NVIDIA is really driving the creation of microservices, right? Which they refer to as NIMs, NVIDIA Inference Microservices, where these are prepackaged little, already calibrated models. And so in the future, you could sort of imagine stitching these together, right, where you create your pipelines by stitching, full capabilities together, as opposed to reinventing the wheel.
Has anybody looked into low code AI? Low code or no code AI? It's kind of an approach to minimize the amount of programming that people need to do in order to stand up a model.
Yeah, I'm not familiar of any low code AI tools other than just consuming what's out there. I'm definitely familiar with that from like the low code or no code database. Do you have an example of tools you've used in this space?
I haven't myself used these. This was suggested to me by a researcher on campus. But I have a list here from a Forbes article. The Forbes article titled "The 10 Best Examples of Low Code and No Code AI" from December of 2022. And a few of the examples are Amazon SageMaker, Akio, Apple's Create ML, and there are many others. I haven't had the time to look into this, but it would seem to address the concern that some of the people in the chat are asking about, and we've talked about here, democratizing or lowering the barrier, at least not on the hardware side, but on the software side, lowering that barrier to entry.
Yeah,
I think
in general,
be a little careful. I apologize. I think we need to be a little bit careful. There are a lot of traps when you're entering, the biostat field, and this is not your area of expertise. I've dealt with grad students that are mixing together their training data with their test data. There's all sorts of things that you can do that basically turn your output into garbage. if you really don't want to learn the details of this, I would advise you to look for a tool that's pre-built by professionals and use that. If you are willing to get into this and learn the details, I'd go for it. But we have to be careful at this stage. It's not, there's no safe keywords at this point.
Totally agree. And you know, in this space, you know, I personally am a big fan of literate science, right? That is, you know, Jupyter notebooks give a really nice environment for encapsulating documentation, code, modeling, and outputs all within the same form factor. And so providing, you know, these Jupyter notebooks, which preserve, you know, present as templates where someone can spin one up and start going through it and twiddle the bits directly in the notebook, I think is just a very powerful paradigm. And I think that's where I usually start with my projects.
Yeah, I think
I
in
have
general
some comments on it. Okay, when we talk about low, LOW, and no, NO, no coding or low coding AI, actually, I pursued that because I had my job experience suffering a lot because I don't trust the human or hand coding. Why? Very hard to, you know, to make it adaptable. So that is why I came up with an idea about DNA-like pure data as a sampling. Then, other than that, all the kind of coded stuff like intelligence put into the knowledge base, then the users use their pure data in the format we call CSV, comma separate value. That's pure data like DNA, and it can be encrypted. And then in that case, you can test the information right there. Even something wrong, for instance, remission of parameters, then it's going to be reported. So that is really low coding and more like no coding. But also we have another solution, it's called codification. What that means, if you contribute some good coding, it's very easier to be adapted into the knowledge base. Then you become no coding again. So that's our current solution. Thank you.
Yeah, I have some additional thoughts to offer. So I think it all depends on the user and the field and kind of their goals. I think low code or no code solutions can be the right solution for certain people. And as John was mentioning, they're safer. But it totally depends on what that person's learning trajectory looks like. Maybe they would benefit from learning some Python code, if that's going to be coming up in their work and their research a lot in the future. So that's how I tend to look at it. The researchers I tend to deal with usually are writing code with their colleagues, and they're doing more than just a machine learning project. And so for that reason, I tend to stray away from low code solutions for the most part. But maybe in a few years, once there's better solutions out there, maybe I'll change my mind. We'll see.
It may serve as a straw man as you kind of explore an area, and then based on what you learn with one of those low code, no code approaches, then when you're ready to kind of, okay, we've got our feet on the ground now, then you go into more of a full-blown development process.
Yeah, definitely. It could be used as a learning tool as well. Yeah.
I would suggest if you're going to use, how can I say it, external software, stuff that's not in your machine, but on the web and things, that you create a test data set that's similar to the problem you're running. And every week you run that test data set and see if you get the same answer you got a week ago. Because if you're using open source software and the developers find a flaw and fix something, you might drastically get a different answer and not realize that something's changed. So you need some sort of quality control mechanism that you have control of, all right? And you routinely run it, maybe not every week, but once in a while, you should have a plan to, I'm going to make sure I drive a pickup truck. You know, I walk around that pickup truck about once a week to make sure all the tires have got air in them. All right. And I don't have a tire that's going low. Well, that's the same way with code that you're running in these environments that are external. You need validation processes to make sure that something didn't change because some flaw was found and the developers went and fixed it. And all of a sudden now you've got a different answer and you're thinking you did something wrong when you didn't do anything wrong. They changed the code on you. Okay.
I have to be very excited to reply to yours. You hit the head on my nail. I had a job experience struggling with Microsoft, iOS, those kind of things. But sometimes it works perfectly, make it easier, no coding, low coding. But all of a sudden it's not working, you have no clue. Eventually they upgrade it. So that is why I started creating my personal platform. I called it WISE CIO, Cloud Intelligence Outlet, CIO. And it's a lightweighted platform. So I never got that kind of negative effect by utilizing some external resources. But this is also open source only with Linux, the purely DNA data, that's very pure. So yeah, thank you. Yeah, I like that part. And also I am personally experienced this and enjoy it.
Should we maybe go on to the next question?
Yeah, sure. I guess we pretty much answered this slide. Yeah. All right, hang on a sec. Let me get there.
Well, so the first question is fairly easy for me to answer at the Fred Hutch. We are tracking a definite trend towards larger RAM GPUs. Previously, the ideal HPC node was a node with many, many, many small GPUs, small RAM GPUs in it. So you'd have a node with 8 or even 10 GPUs in it. And now the new stuff that we're getting, we're looking at, only 4 GPUs per node, but they're the ones with really big RAM. Large RAM is necessary pretty much for any high parameter based model. That's a biostatistical term, but generative AI stuff, all the most recent stuff, you really need the big RAM chips. So that's a trend that we're definitely seeing and investing pretty heavily in here at the Fred Hutch.
Yeah, so lots of trends in the GPU space. If you've been following, GTC and announcements of NVIDIA. So trends are we're going to see fewer PCIe GPUs going forward, with focus on NVLink, SXM4, 5, and more complicated topologies. We're seeing NVIDIA, control the entire ecosystem, moving to Grace Hopper and Grace Blackwell in the future, where you're going to have to support mixed architecture and support ARM architecture in order to get sort of the hero class, right, or capability GPUs. If you're at the data center level, my condolences. By next year, an NVIDIA rack of equipment is going to be 120 kilowatts per rack. And we're expected to be about 250 kilowatts per rack by end of the decade for dense GPU workloads. In terms of people purchasing GPUs, what I see the mistake people over and over again make at the university level is building out capacity and capability at the same time. H100s are great, but they're $30,000 each, and a big H100 box is 253, 400K. And the way Slurm schedules GPUs, it doesn't make the greatest use of hardware. As a nation, if you look at our national HPC centers, average GPU memory utilization is under 25%. So I think we, as cyber infrastructure providers as well as users, need to right-size our workflows. And one particular GPU I like to point out is the L40S. The L40S is about $8,000, while an H100 is $30,000. And the L40S has twice the FP32 performance of an H100. FP32 is single precision. So if you're working on a mixed precision workload, you're doing some inference, or you're able to use Amber and you're able to do MD at single precision, you don't need an H100. An L40S is amazing science per dollar. Lastly, I would look at any technology that fractionalizes GPUs and does better GPU scheduling. because they're a finite resource that takes lots of dollars, and we're not using our GPUs as well as we should in terms of its utilization.
Yeah, so to provide a little bit of additional background about what Christopher just said, the reason why we're not plugging 8, H100s in a single node is that specifically with Slurm, which is also our scheduler here at the Fred Hutch, you're kind of grabbing the whole node, right? Slurm does not slice things up by GPU very well. So it actually makes more sense for us to have multiple nodes with the large GPUs. We love the L40Ss. In fact, we're getting the L40Ss as our primary compute node for like all the regular machine learning stuff. We're just getting a small selection of high GPU RAM nodes and we're kind of holding out for Blackwell for those. As far as the new ARM chips, when we polled our faculty, no one's basically using that technology yet. So we're only getting, I think, 8 nodes that are going to have the ARM chips in them. I think the tool sets just aren't there yet, right? Nobody's tools are taking advantage of this at this point in time. However, over this next year, that'll probably change, right? Once the tool sets change, people will start using it, and then people will start requesting it.
Yeah, definitely. So, in particular, he's talking about the Grace Hopper architecture,
right,
which is this cache coherent, right, where the GPU and the CPU have a direct chip-to-chip link, kind of like the AMD CPUs do at chiplet level. So it's a very high-speed connection between a Hopper GPU and a Grace or an NVIDIA's ARM-based CPU. And the GPU memory on those, which is 96 gigs on the current, can actually use the CPU memory as a cache, right? And it allows for much better performance. And the containers available on NGC, the NVIDIA GPU Container Store, do have most of those shared memory or cache coherent memory optimizations turned on. But I think you're definitely right, John, in that the community has not been brought up to speed yet on sort of what these new Grace Hopper and eventually Grace Blackwell systems will be capable of.
Yeah, when we were writing our grant, because of course you have to justify all of this very carefully about how it supports science when you're applying for a grant. We really had to balance, like, look, here's what we need to do our science now. And in our case, the L40Ss were the right solution. But we also set aside a certain amount of funds and here's what we think we're going to need for the science of the future, right? And there were a lot of arguments, a lot of very heated arguments with very smart people about how to divide that up. But that's what we ended up doing in our case.
Do you have some users that want to use the large memory GPUs, even though their workflow doesn't justify it, just because it's the shiniest, newest?
Well, perhaps this is a little embarrassing. So when you're writing a grant, you have major users and minor users. And most of our minor users are only minor users because our current GPUs don't have enough RAM. So they have had to not use on-prem HPC, and they're basically paying to do it in Google Cloud or AWS. And so those are the people that. So the next time we do an S10, which will be 5 years from now or something, that's when those people will be the major users. So it's this weird balancing act when you're kind of at the administrative policy level and trying to acquire funds to do things. So
interesting.
So JP, to answer your question, does Run AI have the answer to the GPU pain point we are talking about? Yes, no, and maybe. So yes, Run AI does a great job of fractionalizing GPUs. It doesn't work with Slurm. It's in Kubernetes, and NVIDIA bought the company a couple months ago. So Run AI is going to be added to NVIDIA Base Command and their commercial offerings. So that usually makes it inaccessible to most EDU just because of their pricing model.
And as far as HPC is concerned, I actually had a number of faculty come to me and say, hey, we want to make sure that you're still going to have regular HPC, right? So not everybody is using GPUs for everything.
Okay, you guys want to go on to the next one?
Sure.
All right. And whoever wants to take this.
Well, for myself, I took some classes through the UW Biostatistics Summer Institute, which is a pretty intensive course series that I found highly educational. It certainly corrected me on a number of assumptions. So that's how I handled this. But yes, we all have to up our knowledge level to be able to do this well.
Yeah. So I'm a, as I said, I'm a, computational quantum. My PhD is in computational quantum mechanics. So I'm like a simulation guy by training. So AI ML is stuff I've just picked up as a hobbyist and then to do support. So as you go into facilitation and AI ML, the first thing you just need to learn is how to manage software stacks. That is, 70+% of tickets around AI ML support is how do I install this package? How do I make Conda and pip work? Help, my Conda environment's now broken. Help, I'm DDoSing your file system, right? Those kind of questions happen a lot. So I would start with, Conda, and I would actually use Mamba. Mamba is a tool that wraps around Conda that has much better, much faster package dependency resolution, sometimes 2 orders of magnitude faster. So start with that ecosystem and learn supporting Python, R, and Julia in that order. Those are the most common languages in the AI/ML EDU space, with vast majority being Python, R a distant second, and Julia a very distant third to R. It's only after you've gotten to that do you really want to look at other areas. The other skills you want to pick up before you even learn AI/ML to support AI/ML workloads is containerization, right? And not necessarily generating your own containers, but consuming containers. Learn what Docker is and why you don't want to use it on an HPC system, what Podman is and how it makes Docker not suck on an HPC system, right? Because of the IAM model. And also learn a high performance containerization engine like Singularity or Aptainer, which all come originally from the same project, but there was a recent schism. But once you've learned software stack and containerization, after that, you can start, developing your actual skills and learning how to do AI/ML. And for that, I would just go to the NVIDIA developers program and start taking their trainings and starting there.
I think about half of the tickets that the scientific computing team sees are actually about software installs. Yep. One of the major deliverables of the scientific computing team is actually they build all the packages on our HPC cluster. So they happen to use EasyBuild, which I know is pretty old, but it's highly automated, so they can update stuff pretty quickly. We are just starting to explore containerization. At this point, it's not really reducing our ticket load, it's just shifting the ticket load. From package build problems to container problems. But if possible, we would love to actually have a set of standard containers, Fred Hutch published official containers that we can provide people that already have most of these tools built into them. But this is something that's currently under development. It's not something that we've got solved at this point.
So Christopher, you put a step in the barrier into getting started, and it's pretty high. You have all these training things you have to learn before you can do something, and I always worry about that.
Especially you have to have software before you can do anything.
Yeah, I know, but I work at an HBCU, and we don't have any of that up and operational. We don't have a systems person that understands the jargon, much less the ability to implement what you just talked about as a training process for a researcher. It's non-existent.
So I apologize. I'm going to go back to pitching Zero Bio, right? Whole reason that this platform has been developed is because, a large number of our scientists are wet lab folks. They're folks that are developing antibodies. They're folks that are, trying to figure out how to cure cancer or doing pathology, et cetera, et cetera. Like, they don't have time to learn any of this IT computer programming stuff.
We have a fabulous ag school. We have 24 people that are in agricultural research but how are they going to? I mean, I interrupted. I'm sorry.
No, you're absolutely right. So again, and I apologize for shilling out our products, but the pipelines are vetted, right? And they're reviewed, they're standardized, they're and it's the actual biostatisticians that have actually built this stuff. So check it out. People can contribute to it, but there is a vetting process to make sure that you're putting in good, valid pipelines. And that's not the only solution. There's other solutions out there.
The six of us should write a proposal to the National Science Foundation. And the idea would be to go to all of these institutions lacking the resources and doing summer workshops on training how to get this stuff going, so that we end up with not one person at these institutions, but at least three people that have the skill set that Christopher was talking about a little while ago, and have it up and operational so that they can take the step into using artificial intelligence in a reasonably intelligent way.
If I can add on, I mean, I think one of the things that's unique about AI and ML, comparing it to facilitating things like just basic software development, is there are a lot of concepts that need to be unpacked. So in addition to having to learn these complex software stacks, there's also a bunch of new concepts that people have to learn. And like you said, it takes a lot of time for people to digest that. And it's something that's hard to distill in a quick way. I mean, we try to do it at our university using carpentries workshops. So we teach like intro to machine learning, intro to deep learning, some text analysis stuff. And so we've started taking the carpentries model and implementing machine learning and AI workshops. But the space of machine learning and AI is so vast and so large that it's going to take more than just these workshops. And so the other thing that's been really useful for us is having a community of practice at the university. One of the cool things about AI and machine learning is that basically every field is using it now to some extent, which means you can pool all of those different people that are interacting with these tools and try to get them to pool their knowledge and share tips with each other. And that puts the responsibility of having to teach these things not just on the two facilitators out of university, but makes it more of a communal learning goal. And so I think it's been a good solution for us for scaling these things up. And it also allows people in the applied areas to talk to other applied scientists. So not just like the CS people that have been doing this for 20 years already, and they're basically speaking in a different language, but having the applied scientists talk to each other and learn these skills together has been really useful.
I found
The concern is that,
Coursera courses from Andrew Eng and Lawrence Maroney have been very helpful in explaining some of the early concepts. YouTube videos have been very helpful. But I went through NVIDIA's University Ambassador program under Fundamentals of Deep Learning to go a little bit deeper. But the training provided in that program was really not enough for me to. I had to be interviewed a couple of times before I became a university ambassador, because the background is the background that's required is just deeper than what is presented in a 6-hour workshop. At our school, we submitted an NIH grant last year to combine AI, HPC, along with biomedical data. And you talked about a community of practice. The researchers that are part of that core team are essentially working with me and themselves to build up an understanding of AI and where their models could be stronger. It's been a kind of a long arc, but I feel that over time it's a lot of self-learning that's required here. You can't just take courses all the time. You have to get your fingers dirty and really study it, because as you said, it's such a broad area.
So I would like to add something on based on this. The general solution of AI is data-driven automation. But the hardest part is adaptability and the application across different fields. So based on this, I would say as my suggestion, based on my personal research and development experience, is going to minimal API toward external resources or low coupling. So then you have shell built up to seal, to wrap your research up. Then minimize the API, no matter what they change. The basic essential things, they must be provided for you to use. Then you do some adaptation that makes you have more freedom or flexibility to do your research with focusing on your topic. You know, there is a saying in software engineering, there's no silver bullet, but you need to make some silver. Maybe you have some silver spoons, silver forks. No, that's not the bullet, right? You can solve your problem. Try to those kind of silver stuff. Then you will be great with your focusing on your research. Thank you.
Yeah, I think Chris and I just had a really nice discussion with Kenan in chat, right? Where users often expect AI ML to be magical, and they often use it as a hammer because they think every problem's a nail, and they forget their basic stats. There's a lot you can do with basic statistics that people forget about, and you don't need to wrap AI ML around everything.
Absolutely.
Yeah, the research grant funding process might be to blame for part of that, where people have this new shiny tool and they want to apply it to everything. So that could be a little bit frustrating. But yeah, oftentimes something like a simple regression model that you can fit, take you 2 seconds to run that code and you can interpret it. That's oftentimes what I end up recommending. It's interpretable. You don't have to use GPUs, excuse me, and it's very quick.
Just because they make a V8 car doesn't mean you have to give up your four-cylinder Volkswagen.
Exactly. Yep.
Maybe the audience doesn't know what a four-cylinder Volkswagen is. Yeah.
You guys want to head on to the next one?
Yeah, sounds good.
All right. Okay, so what resources or techniques have you found helpful in facilitating AI, ML, and DL?
So
the carpentries. Sorry.
Yeah. No, go ahead.
Yeah, just the carpentries. I'm all in on the carpentries. The open source model is really great. David, I actually took that same fundamentals of deep learning workshop from NVIDIA. It was pretty good in the time span that they taught it, but there is a carpentries version that's like 3 half days, so you get more time to digest the material. And how we teach it at UW-Madison is we do a mix of kind of lecture and hands-on coding. So that's the thing about teaching these things is you do need to also teach concepts. It's not always about, getting the muscle memory of coding things out. It's also understanding like, okay, what sort of scenarios might cause overfitting? When do I need to worry about bias in my data? And things like that. So there's a lot of conceptual learning that's got to happen. So carpentries is the first one I'll toss out.
Yeah, definitely. And I think, I already talked about, learning to manage software stacks, but what software do you actually use? And in the AI space, more than any other space, I encourage people just to play around, just experiment, right? Following on what Phil was talking about earlier, choose a small example, little tiny project and problem, and just play with it. And when you're ever trying to learn a new space and a new tools, always Google the word awesome plus what you want to do. So awesome AI. The awesome tag is basically a community of people who put together these curated lists of packages and projects and documentation. And so if I just Google awesome AI, I see 5 or 6 links that are GitHub pages where they just have curated lists of software for you to try to experiment. And that's why I always encourage experimentation. The second bullet point is one of my big motivations in life is to fix how we handle data. AI ML is all about the data, right? As I said, I'm a simulation or a physics guy by training. If I get a negative pressure or a negative temperature in Kelvin, I know my physics is wrong, right? I know something is fundamentally broken. But in AI ML, it's just a data fit, right? It's just a lookup table, right? If you want to, at the end of the day, it's just interpolation based on the data. And so if your data hygiene is not great, then you can't expect the outputs of your model to be great. And 95+% of our users in the world today are just keeping their AI data sets on a POSIX file system. And just having that data there that you can interact with has sort of human intervening bit rot, right? You don't capture all the transformations, all the post-processing, all the munging, all the tokenization, all the twiddling of you do. And I can't tell you how many times I've had a support ticket of some software doesn't work, and I go in the end of it, and some new Vim user wrote a :Q to their LAMPS input file, right? As they were trying to quit Vim, so they could no longer run the job. Well, now you have that data just sitting there the same way that you can interface with it. So I think as a community, we need to start thinking about, some tools that do a better job doing data traceability, hysteresis, provenance, governance, access, auditing. And there's a ton of open source tools out there that I would encourage people to start looking at. And I'll put a list of tools in chat, and I'll shut up now.
I'm going to follow up with you. Thank you. I used to work for the US Navy because back then we just want to promote interoperability among different systems like the US Army, US Navy, and the US Air Force. But what if we say garbage in, garbage out? So that's why we create a kind of testing bank or bed to purify data in the first place. Then we're going to promote interoperability, or it would be horrible to predict what would be happening because of the nonsense or garbage data. So yeah, I agree with you. So purified data is the first place. No garbage, maybe more like DNA-like ingredients. That's more important. And also very easy to verify, to purify, to guarantee, to predict, or to tracking on the right outcomes. Thank you.
Yeah, man, the other thing I want to just reiterate is, again, there's a lot of fields using these tools, and oftentimes they don't have great support networks. Even like a grad student's PI or their advisor won't know how to use these tools, but they're assigned the task of using these tools for the research. So again, I think providing peer networks, ways that people can interact with the experts is really the key here. And so the community that we run at our university, we call it ML+X, where X stands for whatever field, and we're applying machine learning to all sorts of fields. And we host like a monthly forum where people can get a sense of what is actually possible in this area because it is so fast. And so having talks where people can just learn about what can AI and ML do for you has been really helpful. We also host a hackathon once a year, which is great for teaching people how to use these tools because, again, you need to kind of just get your hands dirty, see how these models interact with data. And sometimes starting with something like a Kaggle hackathon is easier than jumping straight into a research data set that needs to be cleaned and has outliers and has other issues with it. Yeah, those are the two things I wanted to mention.
We have a question in the chat about success stories for generative AI. And so if anybody has got one, that would be good to discuss.
So generative AI is kind of a loaded term. I just, in the context of large language models, which oftentimes you can consider as generative models, that is used oftentimes with like predicting drugs and predicting protein function. Anytime you have a sequence of data and you want to use that input sequence to predict an output sequence, that's where large language models come in. And that's what ChatGPT is. That's what these GPT models that have become super popular are. So in that sense, generative models are very useful in research. If you're talking about those kinds of models used to like generate text or generate pictures, I don't know of any generative models that have been used for research in the context of images, like generating images. However, in text, there's some people at our university trying to use it to kind of automate some of the boring parts of science, like collect, aggregate a bunch of papers and try to summarize them and automate the boring stuff that's involved in research. So these tools can expedite your work if you use them responsibly and you don't expect them to give you the truth, then, then they can be very useful. But they make mistakes all the time.
Can you really use generative AI responsibly? No, I'm just joking. But I said this in chat. The one application where I thought was pretty cool is I'm working with a researcher who's teaching a class on media literacy, and they're using generative AI to generate bogus stories and images and movies, and trying to educate their students that way. And the students are also using the tools to try to fool each other, which is a really fun kind of game, and also teaches them sort of how the tools work and sort of common things to look for.
So I'm going to offer something that's perhaps slightly inflammatory. Last week, I attended a wonderful lecture by a visiting professor from Stanford. And he basically was studying ChatGPT use in research papers. He had identified a number of words that ChatGPT will use that human beings do not use in writing. According to this, his calculation was that approximately 20% of the research papers written in the last year in the US utilized ChatGPT. However, he also did this same thing for reviews of these research papers and found that 30% of the reviews were generated by ChatGPT. So we literally have, AI writing research papers to be reviewed by AI. Anyway, this is inflammatory. Lots of people got upset at this meeting. I just wanted to tell you, it's out there, right? We're going to be dealing with this over the next few years. So I hope your institutions are considering getting prepared for it.
Yeah,
So
sorry, I was just going to say really quick to Christopher's point about like, is it possible for any of them to be ethical? I think what part of that equation might be is that with ChatGPT, at least, there's not a whole lot of consent they use to acquire their training data. And so the things that are generated often reflect work that is copyrighted, but apparently it's subtly different enough that we can't sue in a lot of cases, but in some cases they have successfully sued them. So I don't know. We're entering a strange legal time. I don't know if copyright's going to exist in the next few years. We'll see.
I'm going to tell a short story. In the 1950s, I was reading the St. Louis Post-Dispatch because I was selling it in the afternoon. Okay. And they actually had a person called an editor who actually read the articles that were written by the writers before they got put into the newspaper. Okay. We are greatly lacking the editorial review process.
Very true.
It just gets dumped into something and comes out, and then that's it, And it may be true, maybe not. Just in this meeting the other day, let me see if I can find my note. I wrote a note down. There was a discussion about the Dunning-Kruger effect, and I'd never heard of it, so I went and looked it up, and then I did a drill, and in the drill down, I found people who said, "Well, it's really not true. The Dunning-Kruger effect is probably not really what we think it is." Okay, and so you wonder. People have labels and they put it on things, and that's what AI is doing. It putting labels on things, and anyway.
Well, again, we're struggling through the policy thing. Lawmakers are always behind, cutting edge science, and that's not going to change. Here at the Fred Hutch, we're currently blocking Microsoft's, what do they call it? Microsoft's AI assisted word tools, Copilot, frankly, for ethical reasons. But that probably won't stand. I'm sure as time goes on, people will recognize this as an acceptable tool to speed up the writing process. And the world is changing.
Yeah. Well, when you write a document today and use a word processing system like that, I have a suggestion to the audience and my fellow reviewer discussers here. Read the thing backwards. Go to the last sentence and read the last sentence, and then read the sentence before that, and see if what you've written with whatever tool you've written it with, okay, still tells the story you want told. And you ask me, well, why read it backwards? Because the human brain speed reads when you read it forward. All right. And we need to put our intellectual effort into understanding what it is we've written. So read it backwards.
You want to head on to the next slide, you guys?
Sure.
And so what's the worst mistake you've ever made in facilitating researchers' use of AI, ML, and DL in their research, and what did you learn from it?
So one example comes up. This isn't for facilitating, but in my own experience as a machine learning practitioner, it's kind of related. When I first got started as an undergrad trying to do clustering, I was trying to cluster some data, and this clustering algorithm had all sorts of hyperparameters, like 20 different hyperparameters that would kind of subtly adjust the result you get from this algorithm. And so I tried to do what's called hyperparameter tuning, where you try a bunch of different combinations of hyperparameters to get the best clustering results. And essentially, the data to start with was garbage in, garbage out. And I had not explored my data sufficiently. And so I basically wasted all these compute resources trying to come up with the best result for this garbage data set. So it was a learning lesson, and it's something I try to teach everyone that I interact with is before you get, all in on modeling and AI, plot your data first off, visualize it, get a good sense of it, run some basic stats, get the mean. Don't treat these tools as a black box that's going to fix all your problems. You need to understand some properties of your data before you dive straight into using these tools.
Along those lines, one issue I ran into was a data set where one category was represented much more than the other categories. And when it comes time to train a model, you divide between your training data and your testing data and maybe validation data. Well, I didn't look at the data set, and my training data, just because the code just divided the data for me. Because of that overrepresentation for one category, it really threw my results off. I was not generating as accurate a model as I thought in the general case. So just agreeing with you, look at your data, understand how your model is going to use your data, and hopefully you'll avoid the problem I had.
Were you able to reduce the data set size that the overrepresented data and make it work better?
What I ended up doing is selecting for the training data proportional representation, so that I made sure that the training data and the testing data had the same percentages, well, similar percentages of each of the categories from the larger data set.
Okay, thank you.
I think for myself, one of the most important lessons I've had in the last 3 or 4 years actually is more to deal with working with people than it is actually working with technology. My particular team, the team that I'm part of, we don't only serve data scientists. We don't only serve comp sci folks and biostatistics folks. And it's very easy when you're part of an educational institution to sort of like move into teacher mode. We're like, here, let's talk about how we can help. And a lot of scientists, this is not a part of their professional advancement, right? And we have to support those people too. So, figuring out, how much work are you actually willing to put into learning the skill sets you need to be able to do this versus like, do you just want to use like a pre-built pipeline that, we've already made for you that's already been vetted by, are you looking for a biostatistics consult or are you looking to actually pick up the skills, right? This is a kind of an important question, I think, to figure out pretty early on in conversations with folks. And I no longer believe that one group is more important or better than the other group. They both are contributing, so just in different ways. And that was something I had to learn.
I have learned one thing with the sampling number of the samples. For instance, we discovered a website that has more than 400 web pages, numbered 1, 2, till to 400. One of my students, he utilized the strategy of machine learning, put it from 1 to 400. But he did not realize that got our system stuck. Why? Explosion with too much space needed. So after that, we set up kind of alert. If the space is utilized maybe up to 80% or 90%, we just alert, stop or something to have kind of prompt for the users to intervene. So this is, I would say, sometimes AI is too powerful. You just input some prompts. From 1 to 10, from 1 to 100 is okay. But from 1 to 400, that is going to cause explosion. So this was some good lessons I have learned when my students doing some work. I don't want them overuse something, but not for the goodness, right? Thank you.
I think Sheldon brings up a very important point. At the HPC level, we have to provide safe environments for students to learn how to do things and break things without interfering with the rest of things. This also applies to machine learning, AI, generative AI stuff. So when you're writing your grants and getting hardware, make sure you're setting aside a few nodes that will be separate that people can test their code on and break stuff without interfering with any of your major pipelines or deliverables. I think that's a key part of architecting this stuff.
And Henry, it looks like we're at time here. I don't know if we can maybe have any last things you want to say, you guys.
It's been interesting. Thank you.
We live in interesting times,
Thank you.
and this is going to be, you're going to hear more and more about this over the next 5 years. It's growing exponentially. So
I've done I did my first AI project in 1977. Yeah.
So just a quick advertisement. If you're at PERC this year, on Monday afternoon at PERC, I'm holding a workshop and tutorial on Grace Hopper from the systems facing side, and I'm also creating the Grace Hoppers users group. We're going to meet bi-weekly online and go through together as a community, both learning best practices for systems and software porting for this new architecture. So reach out to me if you'd like more information.
I'm not aware. What is PERC? I'm not aware of it.
Can you drop your email?
PERC is Practical Experiences in Advanced Research Computing. It's the National Science Foundation's annual research computing conference. It's in Providence, Rhode Island. Rhode Island, end of next month.
Okay.
Will that be broadcast?
Can you drop your email in the chat? Christopher, can you drop your email in the chat?
Sure. My email is in chat.
Thank you.
Okay, if we can thank our panelists, this is a great interaction here.
Thank you.
Thanks all.
Thanks, everyone.
Thanks for organizing. Yeah.
All right. Thank you, panel. Let's give them a big round of virtual applause for such a terrific panel. I'm going to stop the recording, and then I've got a quick announcement.